students. Today we're gonna learn about the first topic of our unit number 13. Okay, so it's all about electrostatics. Electrostatics is the field where we study the electric charges at rest, right? Electric charges are not actually at rest. It just means that we consider electric charges to be at rest, all right? Just like if they are not actually moving in a wire so that they won't produce current in metals, right? So that is why we suppose them at rest so that we can study about their intrinsic properties and how they behave in different situations and all that, right? So first we are going to learn what exactly is electric charge, its definition. So the intrinsic property of matter, intrinsic means just that it's the basic property, okay? It's one of the most fundamental, okay? Intrinsic means fundamental, okay? So the intrinsic property of matter that causes it to experience a force of attraction or repulsion when it's brought or placed near another external charge field. So whenever we just take a charge, bring it closer to another charge, these two charges will experience a force of attraction or repulsion. And this attraction or repulsion is one of the most fundamental properties of matter, okay? They don't originate from another quantity. These are the fundamental properties of matter, okay? They just apply to matter as it is, okay? So this is one of the most basic concepts related to the electric charge, right? So now, as electric charge is the most intrinsic property, so it should be part of the most intrinsic particles. What are the most intrinsic particles? Of course, in an atom, the most intrinsic or fundamental particles are proton, electron, and of course neutrons. But I've drawn hydrogen atom over here because it has just one proton and one electron, no neutron, because we don't need neutrons over here. Neutrons don't really have a charge, right? So a proton and an electron. A proton is a positive charge, electron is a negative charge. It doesn't mean a plus sign would revolve around proton. It just means that the property of oppositeness, right, of these two charges. So if the proton has the positive charge, so it is necessary that the electron has the negative charge because they two must be opposite to one another. That's why the attraction between them happens, right? So how would we come to know that electrons and protons attract each other, and electrons repel each other, and proton repel each other? So how would we get to know about this? Okay, so for this we're gonna just do a short experiment, right? We take two kinds of rods, glass rods and rubber rods, okay? First we take, this is the first case, this is the second case, this is the third case, right? We take glass rods, the yellow ones are glass rods and the orange ones are rubber rods, right? So if we take two glass rods, okay, rub it with silk, what would we get? We take two glass rods, rub them with silk, and bring closer to each other. What would they do? You can actually perform this experiment in your homes. Okay, so if you just bring them closer to one another, they will exert a force upon each other like this. Okay, this glass rod will exert a force on this one, and this glass rod will exert a force on this one, but these forces will be repulsive. They will repel each other. Okay, they won't try to just be in contact with each other. They will try to stay away from each other. Why? Because they both have the same type of charge on their surfaces. Remember that charge can neither be created nor destroyed. It doesn't, if you just rub the glass with the silk, it doesn't mean that it gets or it the positive charge or the negative charge will get created on this glass rod. All right, what happens is that the negative charges on the silk will transfer to the glass rod, and hence, or the positive charges will transfer to the glass rod, making it positively charged, and in return the silk would get positively or negatively, whatever it is, it gets charged also. So both the glass rod and the silk will transfer charge to one another, thus making them electrically positive or negative, right? They actually disturb one another's electrical neutrality. So, when we bring them closer to one another, they will repel each other. Same with the rubber rod. Instead of rubbing it with silk, we're gonna rub the rubber rod with fur. Okay, so after rubbing them with fur, when we bring them closer to one another, they will again, the first rod will exert a force on the other, the second one will exert a force on this one, thus producing a repulsion, right? Now, in the third case, what we did is we take a glass rod, rub it with silk, and we take a rubber rod, rub it with fur, and then bring closer to one another. Now see what happens. Okay, this time the arrows are not pointing away from the rods. These are pointing towards the rods. Okay, so for the glass rod, it will try to attract this one. Okay, and for, okay, I have to make it like this. Okay, it will try to attract the rubber rod, and for the rubber rod, it will try to attract the glass rod just like this. Okay, that's why we have made the arrows in this direction. They will try to attract one another. So from this experiment, what did we get? We have obtained the data that there are two types of charges. If the charges are equal and opposite, then they will attract each other. If the charges are equal and same, then they will repel each other, right? So what exactly are these two charges, and what particles acquire these charges? So now coming to the particles. Electron has a charge. Electron is not a charge. Electron is a particle that has a charge of negative 1.6 into 10 raised to the power minus 19 coulombs, right? Coulombs is the unit of charge. All right. Coming to the mass, electron has a mass of 9.1 into 10 raised to the power minus 31 kgs, right? So electron has both mass and charge at the same time. Coming to the proton, proton has a mass of 1.67 into 10 raised to the power minus 27. There is a little minus over there, okay? Make it more visible. And a charge of plus 1.6 into 10 raised to the power minus 19. And again comes the coulomb. Coulomb is the unit of charge. Alright? Now, coming to neutron. Neutron is also a particle. It has a mass a mass of 1.67 into 10 raised to power minus 27 kgs. Alright. But it does not have a charge. 0 coulomb. Why? So why does this happen? Okay, so when we look at a proton or neutron, these neutron and protons are made up of quarks. Okay, so if this is a quark, an up quark, a down quark, so inside a neutron, the quantities of up quark and down quark are balanced. That's why they don't have a charge, right? But in proton and electron, in proton there is an axis of up quark. That's why it has a positive charge. In electron, it has an axis down quark. That's why it has a negative charge. Alright, that's why they have charges, and that's why any kind of material, any kind of matter has a charge. Alright, neutron does not have a charge because it has equal amount of up and down quarks which balance each other, and the resultant charge is 0. Alright, coming to electrification, it's pretty simple. Electrification is the process of transfer of charge from one place to another. It's called electrification, right? So we know that charge can neither be created nor be destroyed. Then what happens when we rub things together? What happens when we try to just create a charge? You can say in normal language, we say we created a charge on an object, but we actually don't. What happens is that take a ball, okay, take a sphere, any kind of sphere. When we charge it, when we electrify it, what happens is that negative charge would reside on the surface, and positive charge, which are basically the protons, the nucleus actually, okay, as the nucleus is so heavy it cannot move. The electron can move, and electrons are the basic reason why charge is transferred from one place to another. So in most of the cases, the electrons would transfer to the surface, creating an electrified object. Okay, so charge here is not being created. It is just transferred from the inside of the ball to the outside of the ball, right? So this is just the displacement of charge, which actually just, you can see here, we take a run, it just disturbs the neutrality of any object. Like in the case of wire, the electrons transfer throughout this wire, but electrons do not get out of this wire, making it this wire acquire only positive charges or only nucleus. Okay, nucleus doesn't actually travel. Electron travel from one nucleus to another, and to another one, and to another one, and to another, thus creating an electric charge, an electric field. That is why we have currents and we have all the voltages and all that. But from just now, you have to remember three things, okay? That charges are of two types: positive charge and negative charge. Electron has negative charge, proton has a positive charge. The amount of charge on electron is negative 1.6 into 10 raised to power minus 19. The amount of charge on proton is positive 1.6 into 10 raised to power minus 19 coulombs. Alright? You have to just remember these quantities. You have to remember these numbers. Okay? Alright. So this was all we needed to study in today's lecture. This is very basic concept of electrostatics, and to just understand any other topic, you have to study this topic very thoroughly. You have to understand that charge would never be created. It has to be transferred from one point to another. So in every case, we will have to just have a source. from which charge can be transferred from one place to another. If we just have one body and not the other, then the transfer of charge cannot take place. Okay, just like in this case, we had two bodies, but if we have just one body, just an electron over here, so there won't be any transfer of charge. Okay, so it is necessary to have a two body system for the transfer of charge and for the electrification process to occur. Thank you so much, everyone.